All right, so if you are to a stopping point on your question, where you think you can kind of look away for a second and come back and not be lost, flip to number 7, and let's look at number 7 together. If you're doing something else right now, that's fine. You can stay working on the question that you're on. Know that I'm going to record this and post it online, so you can come back to this video later. But number 7 is a little different, and so I've been going over this with the classes so everybody kind of gets an idea of how to do it. Because this is actually one of the easier problems, but they give it to you in a confusing way that makes it less easy. So looking at this entire problem, what's the only number they give me?
4 and 9.
Yeah, they give me these numbers up here, 4 molecules and 9 molecules. And what makes this a confusing assignment is that they're calling them molecules because they actually give you a picture with the individual molecules. If we set this up like they normally give it to us with molecules, we're going to be using particles on our flow sheet, which has Avogadro's number. We can do that. It's just going to require a lot of work with really big numbers like Avogadro's number, and it's going to be kind of confusing. So what I think is the best way to do this is to do a little bit of cheating and say, they're calling this molecules. I'm just going to pretend that it's moles. And so I'm going to pretend that they're giving me my numbers in moles and that they're asking my answers to be in moles instead of molecules. That way I can skip the Avogadro's number part and just do this as a really simple problem. And so if I think of this as moles, what do they give me? They give me 4 moles of nitrogen and 9 moles of hydrogen. And what do they want to know from me? Well, I got several different answers here. The main answer is the third one here. After a complete reaction, how many molecules, or in this case moles, how many moles of ammonia are produced? Ammonia is my product. So this is just a simple moles to moles problem. I'm starting with 4 moles of nitrogen and 9 moles of hydrogen, and I want to see which one produces the correct amount of ammonium for this product. So I'm going to come over here and set this up. So this is number 7 for the people watching from home. And what I have is, it's going to be a moles to moles problem. And I'm starting with 4 moles of nitrogen, N2, and 4 moles of hydrogen, H2. And what I want to go to, I just want to go to the only other chemical that's there. Chemical B needs to be ammonia, NH3. And I want to go to moles of ammonia. So if I follow, Oh, yes, my bad. 9 on the hydrogen, right? Yeah. Thank you. 9 moles of hydrogen. So I want to go moles to moles. If I look on my flow chart, how many arrows I pass going from moles to moles? Just one. Just the one. And so this is going to be a short problem, but there's still more to do after this. So this one thing, if I'm going moles to moles, it's got to be the mole ratio. So I got to have the mole ratio. I know a mole ratio is moles over moles. And I know a mole ratio has to be B over A. So I take my chemical A here that I'm starting with, and I put them on bottom. So I'm going to have N2 on the bottom of this one, H2 on the bottom of that one. And my final chemical B, is going to be this ammonium, NH3. So I set up my mole ratios. If this is my mole ratio, what are my numbers here? 2 over 1, and the other one's going to be 2 over 3, right? 2 over 1, 2 over 3. And this is math. I can do this on the board without even a calculator. What's 4 times 2? So I got 8 moles of NH3 here. What's 9 times 2? 18. What's 18 divided by 3? 6. So 6 moles of NH3. Okay, so now we've gotten to a point where we can answer 3 out of 4 of those questions there. So first answer, which of these is actually right?
6.
The 6, because I'm looking for the lowest number. So I know that this is my correct answer. And where does this go? This is moles of ammonium, NH3. That's what they asked me to write here. After a complete reaction, how many molecules of ammonium are produced? We're calling our molecules moles. We're just going to pretend. So how many molecules of ammonium did I produce? 6. I made 6 molecules of ammonium. Now, what does that tell me? If this is the formula I used when I made 6 moles of ammonium, how much hydrogen do I have left over? 0. That's my second answer. How many molecules of hydrogen remain? 0. And that also answers the bottom question, what is the limiting reactant? It's got to be hydrogen, because hydrogen runs out, I have 0. So now I have 3 of my questions answered. I only have 1 left, which is how much nitrogen do I have left over? I got to do a little bit of extra math for this. So notice I got 0 hydrogen left. I've made 6 moles of nitrogen. I didn't use all of 6 moles of ammonia. I didn't use all of my nitrogen. If I had, I would have made 8, but I didn't go all the way up to 8. Number 7 and 8 never got made. I stopped at 6. So how much nitrogen do I have? The key part here is I need to reuse this mole ratio. And I need to take my answer and use this mole ratio to turn it into moles of nitrogen to see how much nitrogen I used to make that 6 moles of ammonium. So I'm going to make one more equation starting with my answer here, 6 moles of ammonium, NH3, over 1. And what I'm going to multiply it by is this conversion factor, but it's got to be flipped. I put the top on the bottom and the bottom on the top. That way, my chemical A, which is now ammonium, is on the bottom. So 2 moles of NH3. And I'm going to nitrogen because I want to know how much nitrogen I use. So 1 mole of nitrogen in 2. What is 6 divided by 2? 3. So 3 moles of nitrogen. Now, what does this tell me? This is how many moles of nitrogen I needed to make 6 moles of ammonium. And so this is how much nitrogen I used. If I can spell this. Ugh. This is how much nitrogen I used. How much nitrogen did I start off with? 4. So what's 4 minus 3? 1. So I should just have only 1 molecule of nitrogen left over. So how many molecules of ammonium did I make? 6. How much hydrogen is left over? 0. What's my limiting reagent? Hydrogen. And how many molecules of nitrogen remain? It should just be that 1 molecule. That 1 molecule. So that is question number 7. Reminder to the people at home, if you have questions, or even people in class, if you're outside of class and you have questions, send me an email with a screenshot of your problem, and I will get back to you. So good luck.